Hey, time for your lunch math and history, and we are going to take a look at piecewise functions. So in the past, we've been doing a lot about y equals mx plus b. Also, with the x of x equals some kind of random number. But also, we were saying if x was some kind of number, then what we would do is input that into our function to see what we get. So we've been doing that in the past, but hang on. What about piecewise functions? Well, what if I told you that piecewise functions actually come in many different pieces, like right over here? So right here, we have the function of x equals 3 parts. 3x if x was less than 0, x plus 1 if 0 is less than or equal to x, which is less than or equal to 2, and x minus 2 squared if x was greater than 2. Hang on, how are we supposed to figure this out? So, a piecewise function is supposed to help mathematicians and anyone understand and try to understand that there are many different parts to a single function. And there are also many different formulas that could be connected to a single function. So what we're going to do is try to find the function of -5 and the function of 2 onto this piecewise function. So there are two parts to doing this. The second part is going to be a way to determine which the first part you'll be using. The second part is called the domain, because whatever you put into x, like this -5 or this +2, will be put in here. Only one out of the three will work. So out of what we're going to do with this one, only one will work. The only one that will work will also mean we have to plug it in to x to get to our final answer. So this part is more on deciding what to do.
Hey, this is Charles. I'm following up on that disturbance we saw at the bridge.
Yeah, turns out the top ad leaders are here. Wait, is that Henry? Henry? Come on, help me take down the top ads.
What do we do?
And the other part right over here is deciding what will happen after you know what to do.
5, 4, 3,
This is
2,
quite the predicament.
1.
So let's start doing the problems. So we have the function of -5. So out of which of these scenarios or pieces, what can we do? Well, if we try to do the bottom one, x is greater than x is greater than 2, and we plug that in for -5, will not work.
Yeah, I have this thing here that can manipulate gravity. Should be able to get you to float across. Let me just... wait. Up. Down. Did it work?
Actually, that's a fail, because x is greater than 2, and it turns out -5 is not greater than 2. So the bottom one we can't use. What about the top one? Is -5 less than 0?
I remember this. Good thing nobody knows about this or we'd be in a lot of trouble. Oh, hello, Mr. Spider.
Yeah! So if that is true, it means the other ones are not true. Meaning, we have to put 3x in for -5. So we have 3 multiplied by -5 is going to be -15. So after putting -5 into the function that makes sense for the f of x, that tells you that -15 is your answer for this case scenario. How about for the function of 2? So for the function of 2, let's try Is 2 less than 0? I thought so too, which I don't think that is less than 2. Or less than 0. How about the bottom one? Is if x is greater than 2, is 2 greater than 2? Yeah, I don't think that's a good option either, because 2 is the same thing as 2, which I don't think is gonna work. How about the middle one? X plus 1. Here is the decision. 0 is less than or equal to x, and x is less than or equal to 2. Is 2 greater or equal to 0 and less than or equal to 2? Yeah, it definitely works. 2 is greater or equal to 0, and 2 is equal or less than 2. Meaning we have to use the middle one. So for the middle one, we're going to have to do x plus 1. So that is going to be 2 plus 1 equals 3. And 3 is going to be our option and our final answer for putting it into a piece that makes a lot of sense for this function. If we know how to interpret this and understand our piecewise function, well, what we're going to do is try to look at a graph that looks like this and try to make our own piecewise function. So let's get started. What we have to do is make something where we find the slope of the line on the graph, and then we also have to find the inequality where it follows that slope. We're going to keep this one on the top so we can model it after our new one. So let's get started. At first, we have to write f of x. And that is going to equal, we have to add this sign right here. That tells you that there are many different lines that are not connected on the graph. Which also means that there are many different parts that are not connected on the graph. Or should I say pieces, because there are a bunch of pieces. And in order for a mathematician or anyone to solve these things out right here, we have to choose wisely on which one we use. So here's what's going to happen. Let's take a look at the first one. So we're going to calculate the slope of that. Turns out it goes down by, here we start, we go 1, 1, 1, 1. So we understand that the slope is going to be negative x because it's going down of 1. What about the y-intercept? It's going to be at positive 1 if you continue the thing. So negative x plus 1 is going to be for part number 1. What about part number 2? It's just a flat line right there. What are we going to do? Well, since if it's at the line of 0, it's not really a slope, and there's also a 0 slope. There's no slope, but it's a good idea to just put the number 0 right there, because y equals 0 if it was a slope, even though there is a 0 slope. What about the last one? Right here, we can start here, down 1, left 2. So down 1, left 2. Meaning if we go 1, 2, 1, 2, meaning that's going to be a positive 1 over 2x. But what about the y-intercept? I marked out the y-intercept because this wasn't assigned for math for homework. It's 1, 2, 3, 1, 2, 3, 4. So it's going to be 0, negative 4 as the y-intercept. So we have to subtract that by 4. So we are done with the first part when we talk about the slopes of the different lines. Now we have to find what happens if we try to find the inequality that perfectly represents the slope on the graph. So let's get started. Let's take a look at this one. We have a bubble right there that's open and an arrow going all the way over there. If you count 1, 2, that means that there is going to be negative 2. and x represents the line right here. So what's going to happen is, if negative x plus 1 happens, if only, here is what's going to happen. X has to be less than negative 2. So that is going to be the inequality for this situation, because here's negative 2 right here on the x-axis, and there's a filled in bubble right there, meaning that it strictly says any number that is less than negative 2 is going to work, and it's also going to be a function, and it allows you to put negative x plus 1 as an unlocked thing to do to search for here and here. What about the second one? We have a slope of 0. That is going to be the first part. But what happens if we try to find the inequality? We have negative 2 to the left and 1, 2, 3, 4. So here is what's going to happen. Negative 2, x has to be greater or equal to negative 2, but also less than or equal to positive 4. That tells you that x is strictly having to be on the line or on the dots. So that is going to tell you that any number right over there helps you unlock the rule for this, and it helps you do 0 when you're trying to solve for this and that. What about the last one? We have, here's 4, positive 4, and increasing right over there. So right over here, x must be greater than positive 4. Meaning that this is now complete. We now made all the parts and the pieces for our piecewise function. And when a mathematician tries to understand this, or if anyone tries to understand this, they have to put things into pieces and be wise on what number they choose. And before the video ends, note that the rules on the domain, this part is called the domain because you're putting what you learned in here, the number, into here to determine what you put in for there and find out what you get for your answer. The domains are not going to be the same, they're not going to be the same when you have a piecewise function. They're just separate rules. Because remember how we had to choose only one option that works? Well, if you had 2 options that work, that means the math would be a lot more confusing. So, yeah! I hope this video has helped you understand piecewise functions. Thank you for watching Top Analyze Math Industry. Like and subscribe.